Cars have gone from this motor wagon in 1886 to this Bugatti in 2022. And with it, the need for passenger safety has skyrocketed. Today, cars are built with the strongest steel, some have parts from space shuttles, and they're tested with the most intense accident scenarios. Here's how cars are made safe. Welcome to Explained. Car design and performance has made incredible progress over the years. They've gotten cooler, faster, and smarter. But road accidents are a lot more common as well. In fact, the World Health Organization says car crashes cause almost 1.3 million deaths worldwide every year. So to counter poor driving, car manufacturers are focusing on safety more than ever. But what exactly goes into making a safe car? First of all, car safety isn't an afterthought. It starts at the design stage itself. To keep it simple, cars are designed with a super strong center cell around the passenger compartment. They also have crumple zones. And these buffer areas at the front and back of the vehicle are designed to deform and absorb impact as much as possible in a collision. The car is then digitally created with technology like CAD, or computer-aided design. And this allows manufacturers to digitally test a new car's design and crash behavior in various scenarios before actually building it. The materials used in the building process are just as important. Advanced high-strength and high-carbon steel are the preferred choice for vehicle bodies, frames, doors, bumpers, and undercarriages, while low-carbon steel is used for parts like the clutch and suspension. But companies like Tesla, that build some of the safest cars in the world, are doing things differently. The chassis and body panels of Tesla's Model S, for example, are largely made from aluminum from Alcoa. Now I know what you're thinking. Steel is stronger than aluminum, right? But to make up for this, early versions of the Model S had super strong boron steel inserts into the side panels secured with aerospace-grade bolts. These inserts were slowly replaced with more aluminum reinforcements like those used in the Apollo lunar lander. And it's so strong that if a pole were to ram into it at a high speed, the pole would stop the car without harming the passengers inside. Before we go further, make sure to hit that like button and subscribe to Explained. Now, testing the crash worthiness of a new vehicle is perhaps the most crucial part of the process. In fact, governments require manufacturers to demonstrate how safe a vehicle is in the event of an accident. Let's look at the most common crash tests new cars are put through. First, there's the frontal impact test, where cars are run into solid concrete walls at specific speeds. Then, there's a moderate overlap test, where only part of the car hits a barrier but is still expected to absorb all of the force. There's also the small overlap test, where only a small portion of the car's structure strikes an object. There's also side impact tests, and these are crucial because these kinds of accidents are the ones with higher fatality rates. You got pole impact tests that test impact on a small portion of the side of the vehicle. And next you got rollover tests that check a car's ability to support itself upon impact. And finally, sled tests that check the effectiveness of components like airbags and seatbelts and whiplash protection.
The measurements from the dummy are then used to judge which seats are doing a better job of moving the head together with the rest of the body in a way that reduces the stresses and the strains in the neck.
In addition, cars are also tested at facilities that can simulate various weather conditions such as water crossings. For example, BMW have test centers 100 kilometers south of the Arctic Circle to test cars in cold conditions. Some even undergo real-world durability tests. Volvo, for example, does a drop test with some of its models to see how falling from a height would impact it. Besides this, manufacturers also test the car's safety software. Some of the most common tech features we see in cars right now include forward collision warning, blind spot monitoring, lane keeping assist, and automatic emergency braking.
Oh my god, no! Okay.
Wow. These systems not only alert drivers of unsafe conditions, they're also capable of taking charge of the wheel in some cases. Pedestrian detection systems are another key feature being introduced in a lot of models. These are tested as well to check if the car can stop automatically if a person suddenly crosses a road, and if the front of the vehicle has a pedestrian-friendly design in case of an impact.
Smooth body surfaces, clearance to stiff underlying structures, and energy-absorbing bumpers are some vehicle characteristics that can help protect pedestrians in the event of an impact.
Testing cars can be expensive, so the maximum amount of data is collected from each test. The test criteria also differs from vehicle to vehicle. For example, an entry-level commuter car isn't subjected to the same testing criteria as a sports car or supercar. And likewise, these will not have to pass the rigorous test of an off-roader. Organizations like the Insurance Institute for Highway Safety in the US and various new car assessment programs around the world like Euro NCAP test and rate car safety for consumers. But here's the thing. Not all supercars are NCAP tested. That's because these organizations are independent, and car makers aren't legally required to use them. So these agencies actually buy cars from dealerships and test them. And it's not feasible for them to crash test every single car on the market. With cars getting faster, smarter, and with the possibility of them flying around soon, it'll be interesting to see how safety features and safety tests evolve along with it. What kind of safety tech would you like to see in cars in the future? Tell us about it in the comments, and don't forget to like the video and subscribe to Explained.